Hi, in this video, we're going to take a look at more angle measures and segment lengths. The first theorem that we got to talk about is if we have this angle from two lines that are inside of a circle, we can find that angle by adding up these arcs and then dividing it by 2. It also works if we've got these two lines that are kind of doing this weirdo thing, where we add these two arcs together and we're able to get that angle. We subtract them and we divide it by 2. Now, this thing that these lines are doing, these guys out here, these lines are considered secant lines. Secant lines are lines that cut their way through a circle, and they might meet on the outside of that circle, which is kind of neat to make that angle for the theorem. That's why it's neat. So let's try it out. So if I were to use my first formula up here, I can see that I have one of those angle ones right here. This angle is being made by these two arcs from these two lines. So I could find the measure of angle 1 if I do half of whatever 59 plus 49 is. So 59 plus 49 is 108. So that means the measure of angle 1 has got to be 54 degrees. And if that is 54 degrees, I know y has got to be supplementary with that. So I could say that y has got to be whatever 180 minus 54 is. So it's got to be 126. Now the other angle that I'm looking for is this angle x, and I've got a semicircle up here, and I can apply this other theorem in order to find it. I can say that the measure of this angle, 50, has got to equal this and this subtracted from each other. I want to do the bigger one, which is my 180 minus whatever x is, and I'm going to divide it by 2 because I almost forgot that divide by 2 right there. So first thing I like to do, I like to get rid of the fraction rather than distribute. So 100 equals 180 minus x. I subtract 180 from both sides, so I get negative 80 equals negative x. So that means x has got to equal 80 degrees. And that's done. Now these diagrams are used for the secant lines right here, but this trick still works if we're dealing with secant lines like in this diagram. So we've got our two angles, 126 and this other one out here, but I've got to find that one by using there's 360 degrees in the circle minus 126. So that means that this arc out here has got to be 234 degrees. So we can find the measure of this angle here. The measure of angle x has got to be 1/2 these two subtracted from each other. So that 234 minus 126. So that means the measure of angle x has got to be 1/2 of 234 minus 126 is 108. So the measure of angle x equals just 54 degrees. And then that is all done there. Now, this next theorem is a set of theorems. It's kind of saying that, hey, if you got this little x, you can multiply these two parts together and these two parts together, and you should get the same thing. If we've got these secant lines where they're going on the outside, we want to use this little outer part multiplied by the whole line. So that whole piece right there. So that's like kind of the whole one. And then that'll be the same as this out part times this whole piece right there. That's that whole piece part 2. Now over here, where we've got like a little tangent line, we end up using this tangent line twice. That's why it's squared, because we don't have an outer and an inner. I'm sorry, an outer and a whole. Our outer is the same as the whole. And then here we've got our out part and then that whole part right here. So let's try it out. In this example, I've got this line, so that is x times 17, that's got to be the same as these two being multiplied together. So that 11 times 10. So if I solve that equation, I end up with 17x equals 110. I divide both sides by 17, and x equals 110 divided by 17, which is about 6.5. About. Um, let's try it again. So again, we've got this line, so I want to multiply those two pieces together. So that's 11 times x. And then I've got this other line, 9 and 15. So that's going to equal 9 times 15. So if I clean up that equation a little bit, 11 times x, that's 11x equals 9 times 15 is 135. I divide both sides by 11. 135 doesn't divide very nicely by 11, but if we round it, we get 12.3 for our answer. So that is those two. Over here on this one, we've got to do some of this like outer part and then whole thing. If I do my outer part here, that is the 12.3. So 12.3 multiplied by that whole thing. The whole thing is going to be our 12.3 plus x. That's going to equal the same thing on the other side. So our 10.7, that is our outer part, multiplied by our whole thing. And that whole thing is these two. So 14 plus 10.7, that is 24.7. So now I just need to solve this equation. I can uh, distribute that 12.3 into there. I get 151.29 plus 12.3x after I do this kind of little distribution right there. And that should equal 10.7 times 12, 10.7 times 24.7, which is 264.29. I could subtract this 151.29 from both sides. So I got 12.3x equals 113. After dividing both sides by 12.3, x equals about 9.2. And there we go. This example down here is going to use that tangent idea. So this line right here is tangent to that circle. So I know that this side squared, x squared, has got to do that same outer part times the whole part trick. So our outer part here is 8 squared. Nope. 8 plus 8 times the whole thing. I don't want to square everybody. This isn't the Pythagorean theorem. The whole thing right here. So it should be 8 times 19. So if I solve this equation, I get x squared equals 152. So that means x equals the square root of 152, which is about 12.3. I can use that same idea in order to figure out what's going on for y, because just as tangent x is tangent to this circle, x is also tangent to this circle over here. So I can say this x squared being 152 has got to be equal to my outer part over here, which is 9. I'm going to multiply it right this time. The whole part, which is going to be y plus 9. I want all of this. Well, I know what x squared is. I just got it up here. It's going to be 152. And that's going to equal, if I do a little distribution, I've got 9 times 9y. So that's 81. I want to subtract an 81 from both sides, which gets me 71 equals 9y. So y has got to equal 71 divided by 9, which is approximately 7.9 for my answer. Now, this last example uses a theorem from another section. If we've got a diameter, it's going to be perpendicular to a chord, and it bisects these arcs as well as this segment. So we know this is 9 and 9, and then we don't know how long this side is. So let's just call it P. So we can use that part equals part when we multiply them together. So we can say 4 times P has got to equal 9 times 9. So 4p equals 81. Divide both sides by 4. So p equals 81 over 4. But note, that's not the whole diameter. I want that whole diameter. And I just found this much of it with that 81 divided by 4. So we just got to add on 4. So the diameter equals 81 fourths plus 4. And so if I type that into my calculator, I get approximately 24.25 for my diameter. Great. That's it for this video. Reminder, these theorems that if you're multiplying parts of segments, you're able to get things equal to each other, as well as this other theorem that if you've got these arcs, you're able to find those measures on the inside. If they're inside, add them together and divide by 2. If their angle is on the outside, subtract them and divide by 2. Thanks for watching. Bye-bye.